So today we are continuing with exponents and we will be dividing exponents. So this is lesson 2 of exponents, okay? Remember in lesson 1 we were multiplying. So some of the questions today will be combining law number 1 and law number 2, okay? So for law number 2, which is division of exponents, this is going to show us why the rule is what it is. So it basically says if you are dividing two powers of the same base, so they have to have the same base, okay? If you're dividing two powers of the same base, then you are allowed to just subtract the exponents, as you can see over here. Okay, now one thing to remember is the first one. So if I write it like this, if I say x to the power of 4 divided by x to the power of 2, this one will always be first, meaning it's going to be 4 minus 2. So it's also first in subtraction. Do not swap them around. Okay, which means the one at the top in this case will also be first all the time. All right, now on my left, or on our left, on the left of the screen, this shows you why the rule works the way it does. Remember, if you say 5 to the power of 7, that means 5 times 5 times 5 times 5, 7 times. And 5 to the power of 4 is 5 times 5 times 5 times 5, 4 times, okay? And remember, we are dividing. So what happens if you divide a 5 with a 5? What happens if we just divide 5 with 5, guys? What do you guys think happens? Anyone? It's 1, right? So all of these 5 divided by 5s are just canceling each other out. And then whatever is left is your answer. So then that means if it's 5 times 5 times 5, that's 5 to the power of what, guys? This numerator that's left over here, the green one, that will be 5 to the power of what that's left over? We have 5 times 5 times 5. So if I write it as a power, I will say 5 to the power of 3. Exactly. Thanks, Butlali. But if you look at our little shortcut here of our rule, this is the same as if we just said 5 to the power of 7 minus 4. So instead of having to go write down all of the numbers that you're multiplying, 5 times 5 times 5 times 5 times 5 over 5 times 5 times 5, instead of doing that, you can just subtract your exponents. Okay, so this is why and how rule number 2 works. The division law number 2. I should stop saying rule. This is a second law. Let me write it down here. This is my second law of exponents. And then I just maximized. There we go. Of exponents. Okay, so it's the division law. Now I have a few practice rounds here for us before we do the real stuff. Number 1 says 3 to the power of 7 divided by 3 to the power of 4. So that's going to be the same as 3 to the power of 7 minus 4, which means this will be 3 to the power of what? What's my answer going to be? 3 to the power of 7 minus 4. So then my answer will be what? It's very similar to our example. Thank you, Logan. It will be 3 to the power of 3, which is how much? 3 to the power of 3 is how much? Remember, if you can simplify, always simplify. Otherwise, you lose marks. 3 cubed is, thank you, Butlale. That will be 27. All right, we're into the swing of things. Let's go to the next one. This is 5 to the power of 6 minus 9. So then it will be 5 to the power of what? So this is important to show you the order, okay? There's something flying in. It does not matter which one is bigger. You always say the top one minus the bottom one. Thank you. It's negative 3. And does anyone know what 5 to the negative 3 is? 5 to the negative 3, if you simplify it, will give you what? Anyone? Someone? Thank you. 1 over 125. When we do the law about negative exponents, we will see why this is the case. Okay. Now, we're on to variables. Okay, we have a to the power of 6 divided by a to the power of 14. That means it'll be a to the power of what minus what? Tell me what I'm subtracting from what? Thank you. 6 minus 14. So then my answer will be -8. Nice. Thanks, guys. And because it's an A and not a number, we can just leave it where it is currently. Okay. If it was a number, I would say to you, we need to simplify this number and work it out. But because it's a variable, you can just leave the answer as it is. We'll go to negative and positive exponents when the time is right. So before I move on, let's have a quick thumbs up, thumbs down. Everyone who is new, that means you go to reactions and give me one of these if you understand, or one of these if you don't understand. And my camera is dirty. I only have 3 thumbs up. 4, 5, 6. Okay, screenshotters. I hope you have done your thing. We've screenshotted this. If I'm going too fast for you, rather take a screenshot. Okay. Nice. Thanks for the thumbs up, guys. Right, I think we can move on. Okay, we have a few more of these. So now we have c to the power of 14 divided by c to the power of 5. So tell me what I'm writing. This equals c to the power of what minus what? 14 minus 5. So then my final answer will be c to the power of 9. Of course, I'm going to write 5. I said c and then I wrote 5. You c to the power of 9. Nice, guys. Now my next one has how many different variables, not how many variables in total, how many different variables. That is true. It has 2 different variables, okay? So I'm going to highlight them. Okay, we're going into territory that is a little bit more shaky. There we go. So there's only one m. So there is actually nothing we can do with m. It's just going to stay as m to the power of 3 in the denominator. But let's look at our n. N's. N is going to be n to the power of what minus what? 2 minus 1. And that'll just give us n over m to the power of 3. So that's also another thing. You leave it in the numerator. You do not put it in the denominator. It belongs in the numerator. Okay, next one. We have 2 variables again. We have an x and we have a y. Okay, so then the only one we can subtract really in this case is the x's. So this will be equals in the numerator x to the power of 12 minus 9 over y to the power of 4. So x to the power of 12 minus 9. What's my new exponent for x? Thank you. It is 3 over, let me move this down a little bit, y to the power of 4. Okay. I'm going to give you guys a few minutes to write, a few seconds, not minutes, seconds to write this down or take a screenshot. Remember, if I'm going too fast, rather just take a screenshot. All right. I'm assuming everyone is done. So now we can move on to this one. So this is what I meant by order, okay? So the first exponent has to come first in your subtraction, and the second one has to come second in subtraction. And now we have numbers involved. Okay, this is where we are going back again. This rule is going to be everywhere. Symbol, numbers, variable. That is very light. Even I can barely see it. So I'm going to choose a better color. There. Let's see. There we go. Signs or symbol, numbers, and then variables. Okay. So in this case, we're dividing two positive numbers. So then my answer is expected to be what? If I'm dividing two positive, thank you, Logan, it is a positive answer. 3 divided by 6 is what? Be careful, it's not 6 divided by 3, it's 3 divided by 6. What's my answer going to be? A half. Thank you, Buhlali. It is a half. And then x to the power of what minus what? It's going to be x. Thank you. 6 minus 4. So then my final answer will be a half x squared. Okay. Now we're into a little bit more interesting sums, but don't worry, hold on to your heads. I have very interesting sums coming. Okay. Now let's look at this guy. Let's look at this guy. If you got this in a test, where would you start? Where do you think we should start with this one? Do you think it matters if we start with multiplying or if we start with division? Buhlali says I'd start with division. Do you guys think the order of that matters? Will it make a difference if you start with multiplication or if you start with division? No, it won't, guys. Remember in BODMAS, or BEDMAS in this case, because we're working with exponents, division and multiplication are usually put under the same category. Okay, so the order does not matter for these two. It's the same with addition and subtraction. Okay, so whether we start with division or whether we start with multiplication, it doesn't matter. I will do both to show you that the order does not matter. I'm going to start with division first, okay? We still have two positives, and we can just divide 3 by 3 and 6. 3 goes into itself how many times, guys? That was really terrible. Once, and into 6 twice. Wonderful. So my answer is going to be, there's a 1 at the top, then I'm going to make my long, nice line, and a 2 at the bottom. Now, x. We have more than one x here, which are divided. So we're going to do what to the exponents since the x are divided? X squared divided by x. Thank you. So I'm going to say then x to the power of 2 minus 1 y. Remember, another thing that you guys make a mistake of, after you do this minusing thing, this x doesn't exist anymore, right? You're basically keeping one base and then subtracting the exponents. So I'm going to write the rest of my sum, which you guys should do too. Right. Equals, so this is going to be x, 2 minus 1 is just 1. So it'll be x, y over 2 times x cubed y squared. Now, who remembers what we said about multiplying with the same base? If you multiply and they have the same base, what happens to the exponents? What do we do with my exponents? Thank you. Or finally, we add them. Now, look, we have an x there and we have an x there. And then we have a y there and a y there. So x times x cubed Tell me what I am writing. X to the power of what plus what? X to the power of, thank you, 1 plus 3. And y to the power of 1 plus 2. And this is all over 2. Okay, this is all over 2. Now remember what I said again. After you place these don't exist anymore. You have just added the exponents, so they're gone. So my final answer will then be x to the power of 4 times y to the power of 3 over 2. Okay, that was our first proper challenging one. So I'm going to say, if anyone has a question, now is your chance to ask it. If you have a question, if you are confused or I have lost you somewhere, now is the time for you to speak up. Raise your hand. Okay, no one. All right, screenshotters, I hope you are done. And then, of course, I'm going to feel bad and go back to being nice. Okay, equals. Now, how many different variables do we have? Let's look carefully. How many different variables do we have? 3. Right? We have A, we have a B, and we have a C. Okay, that 2, we can't exactly do anything about it. There are no other numbers, so 2 is just going to remain 2 in the denominator. So then we are dividing and we are subtracting. So it's going to be A to the power of what minus what? I'm going to put this 2 here because we're not doing anything with it. So it's A to the power of what minus what? 2 minus 1, thank you. Does B have any other partner? Can we do anything with that B? No, we just rewrite it there. And then C to the power of what minus what? 1 minus 1 equals K. Now my final answer, there's going to be a 2 at the bottom. Then it's just A because it's A to the power of 1. B. And what is C to the power of 1 minus 1? What's that going to give us? C to the power of 1 minus 1 is going to give us? No. What's 1 minus 1, guys? 0. But we know that anything to the power of 0 is 1. So then this whole thing becomes 1. So it'll be AB times 1 over 2, which will then be what? What's AB times 1? What's anything times 1? AB times 1 is? It's definitely not 1. There we go. But it is AB over 2. Remember, AB, anything times 1 is that thing itself, the number itself or the variable itself. Think of saying 10 times 1. The answer is 10. 20 times 1, the answer is 20. If I say x times 1, the answer is x. Okay. Are we good with this one? Okay, for the last 2, thumbs up, thumbs down in the reactions. For the last 2 that we just did that are on screen right now, can I have a thumbs up or a thumbs down with understanding? Okay, I have a bit more thumbs up, which is wonderful, meaning people are listening and they're following. Okay. All right, I think we can move on. Okay, now, oh, did I not say I was going to do both for this one? I did. I just forgot. I just remembered. I said I was going to do both first division and first multiplication. So let me do this, put a line there for us because I'm terrible at drawing straight lines. And then this time I'm going to start with multiplication because remember the first one I started with division, right? So it's going to be 3 to the power of x, no, 3 times x to the power of what plus what? Let's say this time we're starting with multiplication. So then it'll be x to the power of what plus what? It's this one over here. That's not a 1. Maybe this color is too dark. Let me do this. X to the power. Remember, this is not in the denominator, okay? It's not 1 over x that. It's x cubed y squared in the numerator, basically. So then it's going to be 3 times x to the power of what plus what? Let's look carefully. 2 plus, we're not adding the one at the bottom, guys. Remember, we're starting with multiplication. We're here now. So we're multiplying these guys over here with these guys over here. So let's check x again. There's x over there. So it's x to the power of what plus what? 2 plus 3. Thank you. And then it's going to be y to the power of what plus what? 1 plus 2. Nice, guys. And this is still all over 6x because we said we're starting with multiplication. Okay, so now I'm going to simplify this quickly. This will give me x to the power of 5, y to the power of 3 over 6x. If I put x times 1 in my calculator, it gives me 0. That's because the x on your calculator is not the variable x. Do not use the x's and y's on your calculator because those are x's and y's you use once you have defined them. So in your memory somewhere, x must be saved as 0. Okay. So we'll go through, I think we should have a calculator skills class. That's a good idea, isn't it? We'll use calculators, yeah? Calculator skills class, show you how to store stuff into memory and how to use them in equations. Does that make sense, Ilham? I hope so. I hope so. You're welcome. You're welcome. Okay. Now we're here. Now we're on division. And now we do the whole 3 thing. 3 goes into itself how many times? Once, and into 6 twice. Okay. So I have a 1 at the top and an x to the power of what minus what? We're now doing the division part of this. X to the power of what minus what? Should I show you guys where my x's are? There we go. Thank you very much, Mutlali. 5 minus 1. Y doesn't have a friend, so it's just y cubed all over 2. Okay. That means this is going to be x to the power of 4, y cubed over 2. Do we see that it doesn't matter whether you multiply or divide first? This is proof. The answers are the same. If you look at this answer that we got here and this one, they are the same. We got there in different ways, but they are the same answer. Okay. Now I can move on to this interesting guy over here. So I'm going to go ahead and ask us, where do we start with this one? Do we just go left to right? I think that makes sense. Going left to right. Right? Yes, left to right, going this way. So that means we're going to start over here. We're going to simplify this guy first, okay? Now let's go for it. We're doing the yellow part. Is everyone with me? We're doing the yellow part. So then it's going to be, if we're dividing, do we add or subtract our exponents? We subtract. So then I'm going to have x to the power of what minus what? Which two numbers am I subtracting? Thank you. 3 minus 1. And y to the power of? Y to the power of, thank you, 2 minus 1. All over 3 because there was a 3 at the bottom. Okay, we're done with this part. Now we're going to move on to the blue guy. Can we do anything to simplify the blue? Is it possible to do anything to simplify just the blue part? No, so I'm just going to rewrite it the way it is. Now, I have a problem with this green part. I say green and then I highlight blue. My brain is not working. This green part over here, that divide is going to mess up our whole sum. So how can we change that 2x, well, divided by 2x to a multiplied by something? Do you remember our fraction rules? How do I change that to a multiply? Anyone? If I want this guy, this divide by 2x to be a multiplied by something, how am I going to change that? What's our rule about changing divide to multiply? There we go, Butlale. So then, this we have kept the same, right? So now I'm going to change my divide to a multiplication. And instead of 2x, what do I have? Instead of 2x, it's going to become what? The flip part of this. We have kept the first one. Let me write here. We have kept this. We have changed this. Now it's time to flip. So what am I flipping? What's my new variable, or what's my new term? What's my new term? If I'm flipping 2x, excuse me, 2x is going to become, no. Remember, if I flip 4, what does it become? If I flip just 4, it becomes, does anyone have an idea? 4 is the same as saying 4 over 1. Do you guys agree? Because this means 4 divided by 1. So then if I'm going to flip that, what is my new fraction going to be? No one? Nice, Botlale. So this would be 1 over 4, which means my new fraction is 1 over 2x. Now I know I might have lost somebody here. Is there anyone that I just lost with that step? Is there anyone who is not quite sure what I'm saying here? Nope. No response means you all agree or you all understand. Okay. Okay, I'm going to go with we all understand. Okay. So now we have our 3 fractions. Now let me update these ones. Now it's x squared y over 3 times 6x over y times 1 over 2x. Now, I recommend we work with 2 fractions at a time. So let's start with these 2 guys here. These 2 guys in the beginning. Okay. Let's multiply across equals. I'm going to write it here because my space is shy. Yeah, my space is shy. Let me do this. No, it doesn't want to work. Let's do that. Okay. So x squared y times 6x. Do we see that both of them have an x? There's my x squared. And there's my x over there. So if I'm multiplying, what do I do to the exponents again? we add them. So then it's going to be x to the power of what plus what? Okay, I'll explain just now. 2 plus 1. And then 6, the 6 has no partner and the y has no partner in the numerator. Okay, at the bottom is just 3 times y, which is 3y times 1 over 2x. I'll explain after the sum, okay? Don't lose patience. After the sum, I'll explain the keep change flip. So this equals, now we have numbers. How many times does 3 go into itself here? Once, and into 6 twice. Okay. So I have a 2 now in my numerator. I have an x to the power of 3. And now what's happening with the y's? Y and a y. We are dividing, so we do what to the exponents? We subtract. So it's going to be y to the power of 0 minus 0. Right, and this is all over 1. 1 minus 1, excuse me. Where did I get 0? I'm already anticipating the answer. 1 minus 1 times 1 over 2x. Okay, if we simplify this guy, it's going to be 2 to the power x cubed, y to the power of 0, times 1 is just that, right? If you times anything by itself, it's just that. Over, what's 1 times 2x again? What's 1 times 2x? It is 2x. And now we're on our final step of division. We have a 2 at the top and a 2 at the bottom that we can divide into each other. 2 goes into itself how many times? Once, and again once. And now we have an x cubed and an x over there. And we are dividing, so we're going to subtract. So it's going to be x to the power of 3 minus 1. And my y to the power of 0 is equal to what? Y to the power of 0, we said is 1. So this is all times 1. So then my final answer is x, I see your final already told us, to the power of 2. That was a nice, lekker, long one. Thumbs up, thumbs down before I explain the keep, change, flip. Thumbs up, thumbs down on this specific question. 5, 6, 7, 8, 9, 10. Okay, it seems like the majority were okay. Okay, let me explain the keep, change, flip quickly. We're going to need it, okay? So when you are dividing fractions, I'm going to start with normal fractions, okay? That are numbers. So if I'm dividing a half divided by 2/3. Yes. Okay. I want this divide to be a multiply. Okay, because multiplication of fractions is easy. You just multiply the top with the top and the bottom with the bottom. So the rule is you're going to keep the first fraction the same. Okay, and then you're going to change this division to a multiplication. And then you're going to flip the second fraction. So this is what I'm saying. Keep means you keep a half. All right. Change, we're changing this to multiply. And flipping means the 3 goes up and my 2 comes down. So this new fraction is going to be 3 divided by 2. Well, 3 over 2. Then it's just multiplication. It's easy. So you're going to say 1 times 3 at the top, which is 3, over 2 times 2 at the bottom, which is 4. Now, what I was saying is, if I just have a number like 2, right? Do you agree that 2 is the same as 2 over 1? Because we cannot flip a fraction that isn't a fraction yet. But do you guys understand the concept that just the number 2 is the same as 2 over 1? Ohlale says yes. Let's hear from everyone else. Logan says yes. Okay. So just 2 is the same as 2 over 1. So now if I'm doing the keep change flip, if I have something like 3 over 4 divided by 2, I can still do the keep change flip because I'm going to keep this as 3 over 4. I'm going to change this to a times, and instead of a 2 over 1, it becomes a 1 over 2. Do you understand what I meant, Elam? Hopefully that was sufficient explanation. Okay, let me move this that way for you guys to take a screenshot. Okay, wonderful. You understand. I love it. Okay, let us. Oh, I have a lot of questions. Let's go to the brain break. I think our brains are a little bit short right now. Brain break. Is there anyone wants to unmute and talk to me for the brain break? I promise you, I won't make you do math. Anyone who wants to unmute for me at the brain break? Chantal. Hi, Chantal.
Hi, ma'am.
Would you rather sneeze every 3 minutes or always have the sensation to sneeze, but you'd never do? You know, when you have that sensation, but you can't sneeze.
Ma'am, sneeze every 3 minutes.
The whole day you're going to be making a noise, sneezing. Oh my gosh. It's not for 3 minutes, but it's every 3 minutes. How many is like I'd rather have the sensation? They don't taste like sneeze. What does everyone else say? Ah, wow. You guys are funny. The sun is like, hey, no way. Guys, that feeling of wanting to sneeze but not sneezing is very irritating. Extremely irritating. Wow. Okay, let's go to the next one. Would you rather spend 5 years in prison for something you didn't do or 10 years for something that you did do? So 5 years for something you didn't do, guys. Would you rather not take your punishment for something you did do? I don't think I can spend 10 years in 5 years in prison if I did nothing. I would go crazy, you guys. I would absolutely lose it. Exactly, you know, at least if I did something, ne, I will console myself and be like, I know why I'm here. Not just randomly kichi kichi. Now you are at prison for nothing. Our guys. No, I'd rather take 10 years, guys. If I knew I did something wrong, I'll take 10 years. Next, would you rather be an amazing artist or a brilliant mathematician? I want to see this. Mathematician, says Mini. Artist, says Buhlali. Artist. Okay. You guys don't like math? I don't like it. At least Lenomta and Mini are on my side. It's fine. And the last one, would you rather win a 2-week vacation or a 1-day shopping spree? In that day, guys, you can buy anything. You're on a shopping spree. Which one would you rather win? 1-day shopping spree. Wow. Okay, guys. Let's stretch. We have We can do a few more. That's smart, Wade. That is smart. Shopping spree means you can buy their vacation. I see you. Okay, let me get going. Let me get going. All right, I'm gonna get rid of this one to make some space. Okay, now for once we have negative numbers, right? This is where the symbol, numbers, variables comes in. Okay, so now we have two negatives that we are dividing. So my answer is going to be a what? A positive, right? And then 6 goes in, 2 goes into, excuse me, how many times? 2 goes into itself 3 times, and in, nope, into itself. I fell for that, into itself, not into 6. Once and into 6, 3 times. So I have a 3 in the numerator. Then it's going to be x to the power of what minus what? Thank you. 3 minus 1. And y to the power of what minus what? 2 minus 3. So then remember at the bottom, all that's left is a 1. So we can just get rid of it. Okay. So 3, and it's going to be x to the power of 2 and y to the power of -1. Remember, it's 2 minus 3. Y to the power of -1. Okay. Let's do this one. It's a little bit more interesting. Now, I have a problem here, over here. Negative y cubed. What's negative y times negative y times negative y? 3 negatives are going to give you a negative. And y times y times y is the same as y times y times y cubed. So this is the same as negative y cubed. So then I can simplify it and then just write 9y cubed x squared negative y cubed. I'm sorry, negative y cubed. Okay, over 12yx cubed. Now, I want us to deal with this negative first. Okay, we are in the numerator now. A positive 9 times a negative times a positive. So in the numerator, my overall sign is a what? Remember, these are all being multiplied with one another. If I have a positive 9, negative y cubed, and positive x squared, thank you, Butlali. At the top, my overall symbol or sign is a negative, right? So it's going to be negative y cubed, negative 9y cubed, x squared, all over 12yx cubed. Now we can do our work. If you are dividing a negative and a positive, your answer will be negative. What is my common factor between 9 and 12? Common factor between 9 and 12? It is 3. Remember, 9 can't go into 12. Be careful of that, okay? It is 3. 3 goes into 9. How many times? 3 times. And into 12? 4 times. Okay. So in my numerator, I have a 3. And then it's y to the power of what minus what? 3 minus 1. Then I just write 3. Isn't that convenient? Times x to the power of what minus what? 2 minus 3. And this is all over 4. Remember, we still have a 4 at the bottom. So then my simplified answer will be a negative 3y squared x to the power of negative 1 all over 4. Let's get a thumbs up, thumbs down on that one. Thumbs up. Okay. Okay, I think we have time for one more. Screenshotters, are you done? Hopefully. Let us do something more interesting like this guy. Okay, how many different bases do we have here? Let's establish that first. How many different bases? 2. So let me highlight them. What are my 2 different bases? Tell me in the chat, what are my 2 different bases? 5 and 3. So we have a 5 over there and over there and over there. And we have a 3 over there and over there and over there and over there. So those are 2 different bases. So I'm going to start in my numerator with 5s. So since we are multiplying in my numerator, what are we going to do with those exponents in the numerator? We're going to add them. So it's going to be 5 to the power of 7 plus 8 and 3 to the power of 3 plus 6. We're going to do the same in the denominator. So it's going to be 3 to the power of 7 plus 1 times 5 to the power of 20 because it's on its own. Now, what's 7 plus 8? It's going to be 5 to the power of 15 times 3 to the power of 9 over 3 to the power of 8 times 5 to the power of 20. Now, what are we going to do since we are dividing? Now, there we go. So it's going to be 5 to the power of 15 minus 20 times 3 to the power of 9 minus 8. What's 15 minus 20? 15 minus 20, negative 5, times 3 to the power of 1, which is just 3. Now let's go on our calculators and figure out what this is. It should be a decimal. It should be a decimal or a fraction. Three over, I'm going to take the fraction one. 3 over 3, 1, 2, 5. Nice. There we go, guys. This is where I'm going to conclude my lesson for the day. I hope we have learned some interesting and valuable knowledge about dividing with exponents. I'll see you guys